Okay, so 1-3 is ordering real numbers. These kind of slid over my little boxes, so you really can't see them very well. All the square roots came out. So you have the square root of 2 plus 4.
What are you doing?
And you're comparing it to 2 plus the square root of 4. Okay? Oh, you guys see? You guys can't see, so it's not going to probably work. Oh, it's working. You can still see it too. Okay. So we're going to estimate these. The square root of 2 is about what? 1 point something, right? Plus 4. We know it's less than 2 for sure, right? So our answer is going to be 5 point something, but it's going to be less than 6. Then over here, we have 2 plus 2, which is 4. So we're going to do less than or greater than or equal to. Caleb, what do you think? That's the greater than symbol you were drawing.
Oh, yeah.
Greater than. So the square root of 2 plus 4 is going to be greater than 4. Anything plus 4 that's positive is going to be greater than 4, right? It imported it incorrectly. So I'm writing them out.
Yeah.
Okay, so now we have the square root of 12 plus 6. And we have 12 plus the square root of 6. So the square root of 12 is between which two numbers?
3 and 4.
So it'd be 3 and 4, right? So if we had 3 or 4 plus 6, our answer is going to be between 9 or 10, right? Yeah. So we can already tell that 12 plus anything is going to be bigger, right?
Yeah.
So you can say that is less than. Because you'd have 12 plus something that's bigger than 2 but less than 3.
Yeah.
It's going to be 2 point something. Okay, so now we're going to order the numbers from least to greatest. We have the square root of 5. We have 2.5 and the square root of 3. Okay? So on a number line, I'm going to do 0, 1, 2, and 3. The square root of 5 is about what?
In between 2 and 3.
It's going to be in between 2 and 3 because 5 fits between 4 and 9, right? And it's going to be closer to the 2 than the 3. So I'm going to put it right here. This is going to be my square root of 5. Okay? 2.5 is easy because it's just halfway. So here's my 2.5. And then the square root of 3 is going to fall where?
1.1 and 2. Yeah, 1.5.
So we'd have 4 and 1 as our perfect squares, right? It's closer to the 4, so it's going to be closer here, right?
Yeah.
So there's my square root of 3. We're just kind of estimating, and that's all we have to do to order those. Okay, so now we know in order we're going to have square root of 3, square root of 5, and 2.5. So we're going to order those without calculators. We're going to do them using a number line. I'm going to do my next set over here. You have pi squared, you have 10, and you have the square root of 75. Hey, Abby, would you shut off the lights for us? It's kind of hard to see otherwise.
Both of them?
Yeah.
Yes.
Whatever helps you the most.
You're right.
Is that good?
Yeah.
Okay. So, pi squared is like 3.14 times 3.14, right? So it's at least 9 point something, right? 9 point whatever. Okay? We have 10. The square root of 75 fits between 8 squared and 9 squared, right? Mm-hmm. This is 64. This is 81. So it's kind of almost in between there. So I'm just going to say it's about 8.5-ish, right? Because I'm just estimating. So if I were to graph those, I would only need 8, 9, and 10, right?
Yeah.
So where am I going to graph pi squared?
Between 8 and 10. Or
It's going to be 9 something, but I think it's going to be somewhere in here. Pi squared.
Yeah, it's going to be 9.8.
I think it's 9 point 8 something actually. But we're getting close enough because of our other numbers. Obviously 10 will be graphed at 10. And the square root of 75 is 8.5-ish, right? So now I can order these as the square root of 75. Then what comes next? Pi squared, and then 10. Any questions on that? So you don't even actually have to do all the math because you can get close enough estimating. It's about this, right?
No.
We're just estimating. So if you're estimating, you would just do it like this. If you're finding the exact, you'd actually probably use a calculator. Okay, so we have a word problem. 4 people have found the distance in miles across a crater using different methods. The results are given below. Jonathan estimated at 10 thirds, which is 3.3 repeating, right?
How does that make sense? Like, they only have one person's on there, but all the heck are they? Kid LaShonda.
Okay, Elaine's is 3.5, so we can leave it as 3.45. Josie was 3.5, right? Which is 3.5. And LaShonda's is the square root of 10. And we know the square root of 10 is somewhere between 3 squared and 4 squared, right? Closer to 3 squared. Or, so I would say 3 point, probably 1 or 2, right? Because it's so close. So I'm going to say 1.5. Whoops, 3.15 is what I'm going to guess it at. I know it's not going to be all the way to 3 by looking at it. So I'm going to order these from greatest to least. So the greatest value is Elaine's, right? No, sorry. I missed Josie. Josie's at 3.5. Jose. 3.5. And you have to write them how they originally were. So 3.5. Then 3.45. And 10 thirds would come next. And the square root of 10. Remember not to put the decimal form that you converted it to. Use the original form that was up here. Okay, so let's do guided practice. Okay, so guided practice is on page 24. And these we're just going to compare with less than and greater than, like we just did on those first 2 examples. So we have the square root of 3 plus 2, and the square root of 3 plus 3. We shouldn't even have to think about that because these are the same, right? And we're adding 2 to one of them and 3 to the other. So what do you think that's going to be? Less than. Good. That one was easy, right? And again, here we're adding 15 to both of them. Which one's going to be greater, the square root of 11 or the square root of 8? 11. So that would be greater than. If you're adding the same, it's easiest, right? Now this one is 5 and this is 6, and we have 2 different square roots. The square root of 6 falls between 2 and 3, right? And the square root of 5 falls between 2 and 3 also, right?
So it's equal.
No.
Oh, yeah.
Which one's greater? 6 plus the square root of 5. Because we know this is going to be less than 3, right? And we know this has to be at least 2. So our answer here is 8 point something, right? And this is only going to be 7 point something. Even if it's 7.99, it's still going to be less than 8.1. Does that make sense? Okay. On 4, it says the square root of 9 plus 3. And that one we can do because that's 3 plus 3, right? And then we have 9 plus the square root of 3. We already know that 9 plus anything that's not negative is going to be greater than 6, right? So less than. Am I going too fast or do they make sense? Okay, so we're doing the square root of 17. That falls, it's almost close to 16, right? So the answer would be 4 point something, minus 3. So this is about 1, right? A little bit more than 1. And this is going to be a -2 plus, this falls between 4 and 5, right? Or 4 and 9, excuse me. But it's closest to the 2. So this is about 0. But a little bit more than 0. So it's going to be greater than. Good. Okay. So we have 10 minus. This answer is between the square root of 4 and the square root of 9, right? So it's between 2 and 3. Even if we rounded high and minus the 3, we'd have a 7 point something, right? And then over here, we're going to have 12 minus 1 point something. So it's going to be at least 10 point something at the very least, right? So it's less than. Now we have the square root of 7 plus 2. The square root of 7 falls between our perfect squares of 4 and 9, right? So 2 plus 2 or 3 plus 2. So our answer is between 4 and 5, right? The square root of 10 falls between 9 and 16. So it's something between 3 minus 1 or 4 minus 1, right? So our answer is between 2 and 3. Does that make sense?
Yep.
So this would have to be greater. Even not knowing our exact answer, we can still see that that one's greater. And the last one like this, again, we have the square root of 17. We already did it, right? And we knew it's about 4, a little bit more than 4, plus 3. We just did it up here, remember? So that's about 7, just slightly more than 7. And then we have 3 plus, well, 9 is here. And then 16. So this one's just a little bit more than 3. 3 point something. So it's going to be less than 7. It's going to be 6 point something, right?
Yeah.
So that would also have to be greater. That one got really close.
But if you look at it, it's pretty obvious. The
Yeah.
square root of 17 is greater than the square root of 11.
Right, because we could have just looked at 3 plus the 17 is bigger. Okay. So moving on to number 9, we're going to order the square root of 2, 2 pi, and 1.5 from least to greatest and then graph them on the number line. Okay? So the square root of 3 is between which two numbers?
1 and 4.
1 and 2.
No.
1 and
1 and 4.
1 and
2 and 3.
It's between 1 and 2, but let's do decimals. Let's do 1 point.
1.0 and 2.0.
Well, if we do the square root of 3, right? Hold on a second. Okay, square root of 3. We would have 1 squared and we'd have 2 squared, right? So it's between 1 and 2. But it's actually closer to the 2, right?
Yep.
So if we were to guess, we would probably start at like 1.6, 1.7, 1.8-ish. Remember when we did this?
Yeah.
What's 1.6 squared? What's 16 squared?
3.2. 32.
What's 16 squared? It's one of your...
It's 3.2. 3.2. 3.2. It's 36. 2, 5, 6. 3 point million. 6.
What's 16 times 16?
32. 256.
So this should be 2.56. And what's 17 squared?
289.
And what's 18 squared?
324.
So it falls between these two, right?
Yep.
So it's between 1.7 and 1.8. So the square root of 3 should be about 1 point what?
1.75.
75. All right, good. Now we know that pi is about 3.14. So 2 pi, if we double that, 3.14 times 2 is 6.28. So now we can graph those. So the square root of 3 is 1.75. So right here, right? This is the square root of 3. Then we have 1.5. Oops, I kind of got that close. 1.5 is obviously 1.5. And then we have 6.28, which is our 2 pi. So if we order them from least to greatest, we have 1.5. We have the square root of 3. And we have 2 pi. Okay, the next one says 4 people have found the perimeter of a forest using different methods. Their results are given in the table. Order their calculations from greatest to least. Okay, so again, we got to estimate here. The square root of 17 falls between 16, right? And the square root of 25. So my answer is between 4 and 5, right? It's closer to the 4, so I'm going to say 4.1, 4.2, probably 4.3 at the highest. So what's 4.1 squared? 16.81 is what I got.
Oh, wow.
And then 42 squared
16.
is 17.64. So it falls right between these two, right? 41 times 41 is 1,681. I don't know how far you guys went on your square roots.
How is 2 times 2?
We didn't go that
So
way.
it's 4.15, right? Minus 2. Make sense?
Yeah.
So this one would be about 1.85. Oh, no, I'm only subtracting 2. I got it backwards. It's 2.15. Okay, and then Micah is 1 plus pi divided by 2. So if we just did the 3.14 divided by 2, what do you get? 1.57 plus 1. So this one is 0.57. Okay, Jason is 12 divided by 5. So 12 divided by 5 is what? 2.4, and then we can leave the 2.5. Okay? So now it says to order their calculations from greatest to least. So the greatest one was 1 plus pi divided by 2. Good. And then 2.5?
Yeah.
And then 12 fifths, because we have to leave them how they were. And then the last one is what?
17 squared take away 2.
Good. And then it says to explain how to order a set of real numbers. We had to convert them all to what?
Decimal.
Convert each number to a decimal. And then it depends on if they say greatest to least, least to greatest, or if you're just comparing which one's greater than or which one's less than. That's it.